One way that you can do synthetic division, and it's usually this applies when you have a linear factor, okay, meaning a factor to the power of 1. Okay, so when you're looking at that, what you can do is you can determine the associated 0 with that factor. Okay, so what 0 is associated with the factor of x minus 3? What value of x gives you a 0 in that factor? 3. So you're going to take that number and you're going to set up what's called synthetic division. And I talked a little bit about this. The way that you set up synthetic division, you take whatever that associated 0 is, and then you're just going to list your coefficients along the top row. And when you list your coefficients, you have to place zeros for any terms that are missing, any degree terms that are missing. So we have our x cubed. What's the coefficient of this x cubed? 1. Then we have to progressively decrease. So x squareds, how many x squareds do we have? If there's nothing there, you do have to fill in a space for that by using 0. How many x to the first do we have? Negative 10. And then how many constants do we have? Negative 24. So if you just place your coefficients, you can use synthetic division to go through and solve this pretty quickly. And the way that you solve it is you just drop down your first term. So that comes down as a 1. And now you multiply whatever this associated 0 is by the number that's in this bottom row. So 3 times 1 is 3. You just combine straight down the columns. 3 plus 0 gives you 3. Multiply through. 3 times 3 is 9. Combine straight down your columns. Negative 10 plus 9 is negative 1. Multiply by 3. Get a negative 3. Combine down your column. Negative 27. Whatever's in this last column is your remainder. And so when you write your answer, all you need to do, because we're dealing with these linear factors, we just decrease the power by 1. So this becomes an x squared, then an x, then a constant, and this remainder you're going to divide over or put over this original factor. So your answer for this would be x squared plus 3x minus 1 minus the remainder 27 over x minus 3. Okay. So again, we can confirm this if we were to just take our expression. Now, if you're doing this on your computer, you do need to put your entire first polynomial in parentheses. So we get x cubed minus 10x squared, or 10x minus 24. We're going to divide that by, put your second expression completely inside of parentheses as well. And when you do that, notice what happens. It gives you the fraction form. What do we need to do in order to get it written as a polynomial? What command converts to polynomial form? Expand, right? So if we hit expand, close off the parentheses at the end, it now puts it in this form. Now notice in the way it wrote it here, it put our remainder in front, but when you write it, I want you to write it in standard form, highest powers first. So x squared plus 3x minus 1, and then minus 27 over the quantity x minus 3.